when similar kind of research
Good
was
afternoon,
performed with
everyone.
human
My name is Dina
subjects,
Abouhelal, and I'm pleased
they all,
to
without
present my
any
research paper titled
the
Enhancing
inexperienced
Circular
construction
Construction
workers,
through Structural Reuse.
they also show
This work
they
was
also
carried out
showed
under the
about
supervision
35
of
to
Professor
40%
Amin.
of accuracy when they were
This is
done,
the agenda of my
when they
presentation.
were not initially trained. But
Based
when
on
they
the
were
evidence
supported,
in Council and the United Stations Global
when they were
Technical
trained
the built
with
environment is
LLMs,
responsible
their
for 20% of the
accuracy
annual
increased
global
to
carbon
about
emissions.
70 to
This
80%.
the urgent
And
to address carbon emissions
even
across
with
construction life cycle.
even the
The
types of
current practices in the construction industry follow a linear supply chain
hazard
based on
that
take
LLMs missed
of
and was determining
consideration of the end of life phase of
was
construction. So there is a need to change this model to a circular
identifying
that
mirrored
keep the resources
the
in
behavior of
use and
human
which will minimize the
subjects.
waste and
So
reduce the
here with this
environmental
research, we are
the deconstruction is a
suggesting
key
that
driver of safer
when AI
by maximizing the recovery of structural
and
components at the end of life.
AI should be
This is the full process of the deconstruction, starting from the
AI
donor
should
structure to the
be
receiver structure. Following deconstruction, recovered materials are either reused or recycled. While recycling structural steel is widely utilized at the end of life, it entails energy-intensive processes such as steel melting and fabrication, which elevate energy consumption. In contrast, structural steel reuse presents a more sustainable option, requiring minimal configuration and reducing the embodied energy and greenhouse gas emissions. Several studies have been conducted in advancing deconstruction at the end of life. However, there is a lack of a comprehensive methodology that integrates the catalyzing factors necessary to facilitate the reuse of structured steel after deconstruction. Also, there is a need for investigating
you said
to derive
why we use only 16
construction practices. So, based on that, our research objectives are promoting circular construction by developing a framework of
firstly, we are just trying to create a baseline
and enable
to check whether the
analyzing the potential
models like ChatGPT
the application of
can perform without any outside assistance.
And proposing future directions for
and again, then with safety experts, we verify that these images are enough and diversified enough to
Phase number one,
the
catalyzing factors,
real life scenario that most supervisors see in everyday life, but they are very probable of missing those kind of hazards. Like for example, we can see in one picture, even in one picture, there are multiple kinds of hazards. So it is very probable that these hazards in one scenario can be missed.
For better identification and analysis of the catalyzing factors, we grouped them into 5 clusters: structure attributes, business attributes, value chain activities, project management, and regulation. Each cluster includes related factors and sub-factors. Due to the time constraint, I will not go into details on every factor, but just as an example.
And that's how we landed on
the structure attributes. The key factors include the structure design, the component condition, and location. And the sub-factors go into more detail, like, for example, whether the structure components are modular, whether the mechanical connections are used, the integrity of the structure, how accessible it is, and its urban context, and so on. The selected case study of our research is the original Champlain Bridge deconstruction. This bridge was one of the largest infrastructure projects in North America. It was built in 1962. The main issue is a severe corrosion which compromised the structure integrity. The planned deconstruction cost was $225 million Canadian dollars, and the deconstruction started in July 2020 and finished in November 2023.
Elaborated description of some
hazards. The total steel weight was
25,000 tons. Phrases that would
for the case of the Champlain Bridge, several factors and dedicated efforts have been conducted to facilitate the deconstruction and promoted the use of structural components at the end of life. For example, for the structural attributes, the main part of the original Champlain Bridge is a steel truss structure, enables the recovery of 413 standardized components for reuse. Also, the mechanical connections facilitated the component separation using techniques like heat cutting for large elements, unbolting, and removing rivets. Also, the proximity of the bridge to the surrounding infrastructure facilitated deconstruction logistics, making the removal and the transportation of materials faster and more visible. Furthermore, the bridge's legacy and historical significance increased the appeal of the salvage components and promoted their use in heritage and commercial projects. For the business attributes, they set sustainability targets for handling and transportation, emphasizing the use of components rather than traditional recycling. Also, they implemented continuous performance monitoring to improve the project's profitability. Furthermore, a sustainability support tool was developed to
when we give images to LLM,
evaluate the deconstruction method,
we would have
the value chain activities.
List of
they enhance logistics by implementing a phased deconstruction.
This can happen on site, and humans can be aware that these are the potential hazards that might happen before they can actually happen on the site. Like currently, humans are not even aware that these kind of hazards might happen when they are on the site. Yeah. Thank you so much.
All right, so next presentation we have is video-based productivity monitoring of workers and large-scale object interactions in construction sites. Whenever you're ready, please.
We have data provided in the catalog to gain some insights related to the quantities and the weights of reusable components. And as we can see, there is a variety of steel profiles that distributed across different locations of the bridge, which reflect their different applications and different structure rules. This is an example of the data provided in the catalog for profile 01. As we can see, there is for each steel profile, there are some information like the function for each component, the length, the weight, the height, the available quantity, and the price. This histogram presents the distribution of the reusable steel components in the bridge. As we can see, the diagonal steel members are the most numerous, totaling around 165 out of 413. And in terms of weight, the total steel weight is 401 tons, and the top chord members have the largest proportion. And finally, moving to the legislation, the deconstruction process was aligned with Canada's National Sustainability Strategy and supported the United Nations Sustainable Development Goals. And overall, the deconstruction process and all the reuse efforts had been supported by financial incentives, including public funding sources such as federal funds, FAIRs, and bonds. So, to enhance the deconstruction process and maximize the component reuse and support the decision-making at the end of life, future research could focus on advanced technological initiatives, such as evolving a product passport system, which is a digital system that details the information of each material component, exists in the structure. So it had the potential to maximize the recovery of structure component at the end of life through matching the deconstructed project elements with the new construction projects. Also, virtual and augmented reality can enhance the deconstruction process through simulating the deconstruction scenarios and understand the best practices for handling components, improving safety, and maintaining the integrity of reusable components. So to conclude, circular construction is a key strategy for reducing environmental impact in the construction sector. Reusing structural steel components as applied in the Champlain Bridge project offers a viable and sustainable alternative than conventional demolition and recycling. Key enablers of successful reuse include strategic deconstruction planning, supportive legislation, integration of digital technologies, and stakeholder engagement. Finally, future research should assess advanced technologies and conduct comparative analysis of the environmental and economic impacts of reuse versus traditional recycling. Thank you so much, and I welcome any questions.